what I want you to do right now is close this 0.1-numpy Jupyter notebook. And, well, this is some other notebook. And let's open let's open 2070 SciPy and website and Python. So for some of you, this website will be 2017-0.7-10-NCSA instead of website here. So I want you to open the 0.2 loops. So we pretty much we are ready for this information. So we talked about strings, and we saw that we can work with several data files in NumPy using mean, average, mean, max, and again mean, but slightly different one, to get minimum value, maximum value, average value. Now we can also work with parts of different entities, objects. For example, in case of strings, we can work with their characters, with characters that constitute the string. For example, if we take the word, like any word, in fact, lead in this case, and we can print out the components of this word just by referencing them using their index. So as before, 0th component is the first one, so it's character L, and index component with index 1 is actually the second, so that's E, and so on. And you can see how we can print out the word just line by line. That's great, but what if we have a different word? Let's say we have a word 10, and we apply the same 4 lines. We use the same 4 lines. We just copy and paste them. Well, unfortunately, we'll get an index error. So we'll get an error. And the reason is straightforward, because we are trying to print word, the 4th character of the word, so character with index 3. And we have only 3 characters there. So what Python tells us is, hey, you are trying to print something that is out of range. And you see an explanation here. Index error, string index out of range. So string index, meaning that you are trying to sort of apply index to a string, and then out of range, obvious. It's pretty obvious. Now the solution is pretty straightforward. We can use a for loop. And here, this is an example of how we can use a for loop. I suggest that you change the word to your name, for example, or anything else, and see how it works. So all it does, it takes character of the word and prints it. But let me walk you through that. So for is the keyword that signifies Python, okay, I'm going to go into a for loop. And again, if you watch that Greg Wilson's video on YouTube where he discusses the advantages of using the word for, it's in fact it's very well, it's not very intuitive word to use for loop. but that's what we use it almost everywhere. There are some languages where you have for each. There are languages where we have for. In Python, we have for. Now, for character in word. So what it does here, it takes a variable word, which in our case equals, well, equals to my name here, but let's do it this way. And then it assigns a character one by one to char to that letter M, then it will assign to letter Y, and so on. It will even print the space here, and I can select it to show you that this is actually a space, so it's not an empty line. The reason I can select it is that it's here. And you can see, so we got rid of that index, the index that was failing for us here, square brackets 3. We no longer depend on that index. We sort of went away from that problem only by using for loop. Yes?
How does it know the length?
It doesn't, like, you can think of it, it doesn't as follows. So it doesn't know the length of it. So what it takes it, and piece by piece goes from one side to the other. Now, all it does, it just takes all the elements one by one in order. Because strings, as you remember, we can refer to elements in order, like 1, 2, 3, 4. Well, I mean 0, 1, 2, 3, 4. So that for loop does just that. Internally, it knows, of course, the length, the size of that object, and uses it. So it uses the knowledge that it has and not the knowledge that it needs from us. Now, this for loop follows a standard procedure, a standard approach in Python, where we say for variable in collection. Then it's important to say colon. Without it, it will not be a for loop. Go to the next line, add spaces. You can add 1 space, you can add 2 spaces, 3 spaces, you can use tab. The only requirement is that if you have multiple lines in that for loop, you have to have the same number of spaces. For example, so this is wrong. For example, that would raise an error, because what Python sees is that, okay, this is a for loop. Then it says, okay, the next line is intended by 4 spaces, but the next line, it's still inside of the for loop, but there are only 3 spaces. So that's a mismatch, and it says, okay, this is an error. And Control Enter, and oops. Okay. A second, let me move that here. Okay. So now this is a way to count number of characters in a word. For example, we say, okay, let's set length to 0. That's the way to initialize variables. And in programming, it's important to always initialize values. There are some applications, well, I'm not going to go into these details. So, so we say that length equals 0. So this is the length that we are going to update. And then the loop, we loop over all the vowels that we know, and we increment length by 1. In the end, you see print is not indented. So it starts at the same level as 4. That means that it's as good as the for loop. So it will be executed after the for loop. And just to show you that I can have as many spaces as we want, I will remove that and I will add just one space. Even though Jupyter Notebook highlighted it, because it expects it to have 4 spaces, this is still legitimate Python code. So you can have 1 space, you can have 2. It will just work. And just an example 2. So this will fail. Okay. Now, let's just see what it does. So if you see, this for loop takes the variable, in this case letter, and it changes at every step of the loop. After it's done, it doesn't care. It doesn't do anything to that. So after the for loop, the variable takes the last value it had in the for loop. In this case, this is C. There is a built-in function called len, and this basically tells you the length of a string. So we can see that the length of that string is 5. That's not very difficult. Okay, challenges. Yes, range. Yes, let's cover that range because range is important. First, I will show you range, how it works, and then you will work on that exercise. So range is a very important entity, feature of Python. So it lets you create for loops easily and quickly over like big loops. For example, for I in range 15. Print I minus 2. Anything. So here I use the range as a way to create a list from 0 to 14, including 14. And I printed values and subtracted 2. Let's have a look at the range function help. So range question mark. This is a Jupyter Notebook feature. So pay attention to this line. Range, start, comma, stop, comma, step. So step is in square brackets, so that means that's an optional parameter. And we used this notation when we specified only one last value. That was not reached, by the way. 15 was not reached. So we can see that we can actually say something like for I in range 3, 15, 5. And spaces are not important here. Print I 2. let's print two things. So here we said that, okay, the first value that we will use is 3. The last value that we don't want to reach is 15. And step is 5. That's it. So now let's do this exercise. So the task is to write a range, a loop that prints 1, 2, and 3. I guess everyone is done? Yes, so the solution is obvious. Range of 3. This one. Okay. Of course, that's not what they wanted. They wanted 1, 4, and 1, and I. But you can choose which one you use. You can either use range of 3 and increment I here, or you can be very specific and say that I want to use, let me have both actually. For I in range 1, 4, 1. Okay. Yes.
Max, could you make the font bigger?
Sure. Yes. Sorry. Whoop. Well, so we are being asked to write a loop that calculates the same result. So we have to compute 5 to the power 3. For I in range 3. We want to have a result equals 0 first, and we say result equals value. Well, sort of doesn't make sense. And then we have result equals result times 5. Now the question is, will it do what I want or not? Correct. It will not do, because it has to be that. Where is it? Oh, I rookie mistake. Result. Yes. So this is how we can use range to do the same thing over and over again. By the way, we can use the same notation as we can use in any language almost, in C, for example, equals, multiply equals. So this is the same as result equals result times 5. Many of programmers got used to that notation, so you can see how this is shorter and quicker to read than this. Okay, so reverse a string. This is the most useful exercise, I think. So that let's use a loop to actually reverse a string. For example, Newton, so that Newton becomes not when. So the question is, will we see what we expect? So first of all, we say str equals Newton. That's fine. We can actually, so str is a keyword, but we can reuse it. That's why Jupyter highlights it in green. New str, we initialize the result that we want to create with an empty string. So this is an empty string. Then we say for I in range, which is perfect. Length of str, good. Then we say new str equals new str plus str of minus I plus 1. So okay, so let's forget this math right now, but what will this do? It will print new str every single time, every single iteration of the loop, because it's indented here. It's at the same level. And we don't want that. We want to maybe output a string at the end of this. So let's see. I'm a bit lazy to do the math now. Let's just see if we get, yes, cool, it works. So the way it works is that we start, okay, right now I will do the math to explain it. So we start with 0. The first value of I is 0. And the first value of str is, so the first index is -1. So this is the last element, lowercase n. Every time we go through this loop, I gets incremented. So in the second iteration, I equals 1. So we subtract more. Str of -2. And that's the second from the end. Oh. So this is a correct solution. The only typo was that print function was printing at every loop. But this is actually a way to see whether you are getting, if you are on the right track. So you would see that. Yeah, this is, I guess that was used just to, yes.
Is it good form to use string str as the new variable?
So you wouldn't use it in a, my guess is that you wouldn't use it in a real program because you want to be a little bit more descriptive. And actually, search online for software carpentry, best programming practices. So actually, software carpentry is famous for the 10, I believe, 10 basic rules for software programming, writing good software. And one of the rules, I don't remember the exact wording, but write for humans, not for computers. So if you name your variable str, it could be anything, right? It could be, I don't know, like yes, 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 strength, or it could be it could hold a string, but like mean string, but something else, like a table, for example, name of a table or something else. Here we are dealing with a first name apparently, and like I would say that the good way to name a variable would be first. Now there is a debate what to use, camel case or underscore name, but that's personal preference at this point. Okay, so this is good. Let me see the other solution. I think the other one was yes. Yes. So the first solution that was very close to the shortest one and to the oh, sorry, it's not X, by Kirill, str. Okay, yes. So, and actually this is not a bad solution in terms of like being very explicit, because what we are saying here is that we are taking this string str. Oh, and I didn't know that I'm standing right here. And the first character that we want to take is length of that. And okay, so the question is, what is this? Like, if we do that, like, what will we get? Error, right? Because we don't have these many elements. But the thing is that when it gets that out of index thing, it just, okay, there's nothing there. And it just continues. So, like, ideal solution would be that, I think, because then you can remove it, remove the length. And here we are not specifying the last element that we want. But that would be that. Oh, the last one is, sorry, -1. We are starting from the end. We are going backwards till we hit, what do we hit? 0? Huh? Well, this will work, yes. And this works too. Now the question is, if I want to be explicit and specify something here, what do I have to say here? And let's just think about it. So the first is so the first element that we will get is that lowercase n. Then we will decrement by 1, so we will get the last one. And if we specify 0, it will not be inclusive. So I guess we cannot specify anything here, because if we specify -1, if we want to go lower, we just lose it. So this is the, I guess, the situation when we cannot specify anything here if we want to. Okay. So so str, let's just call it a name actually. Name. So name, oops, name is a string Newton. Now, if we say we want to start at 0 and end at -2, which is the last element, -1, so we'll get Newt because we exclude the last element. -1 is the last element, so we get Newt. And if we want to get everything, we would get length of name and that. Now, we can have a step here. So default step is 1, but if I do 2, I would get N, W, and O. And let me actually print name and print this so that we see what is being dropped off, removed. So we start with element 0, which is capital N. We skip the next one, E, and then we get W. We skip T. We get O. We skip N. This can be negative. The step can be negative. We can go -1. And we have to skip that because when we have this, we will never reach length of x, which is 1, 2, 3, 6, using a step of -1. So when we say that, we basically say, okay, give me the first character 0, n, then decrement by 1. And when we decrement by 1, we effectively reach the end. And when we skip that, when we omit that last element that we want to reach, it actually equals to the last element, n. And we reached it immediately. That's why we get the last element. Now, if we use that, we say, okay, just print me everything but negative step, step of -1, and it gets that. But the question was using for loops, so let me see. Yes, this is a good example. Yeah, this is a very good example. -1, -1, -1. So it uses plus equals. So this is you can do this with strings as well. It uses range. Uses all 3 specifiers. So we specify the beginning, the end, and the step. Yeah, and use. Great. So this is a very good solution. But of course, nothing beats that. That's much. This is much quicker, shorter. Okay. So we are done with loops. And one thing I should note that remember that we can also iterate over elements of the list. For example, oh, good example. So let's print. So S. I will just continue from the previous example. S. This is a long string. So strings have a method called split. So when we use this method, strings are split using white spaces, and they are split into a list. Oops. So we can store the result of that as list equals as dot split. And we can iterate over elements of the list. Si in S list Si times 2. This is just to show that you can multiply strings. We could use anything here. So we can iterate over list elements as well. So we can iterate over strings, over lists. As you can guess, we can iterate over anything that is similar to list. So 2. Let's close this. You can save this notebook file. Oops, file. And save and checkpoint, or make a copy to rename it as you wish, but I will close it. And in order to stop it, I will select it and click shut down. So you see that it became gray, so it's not running any longer. Okay, lists. Well, we talked about lists already, so we'll just briefly cover them here. Lists can store any data. You don't have to have the same type of data in list. You can have anything here, and it will work. And because of that, they are less optimized than NumPy arrays. And I saw a discussion on Slack channel that, and there was a correct comment that the next step after NumPy is SciPy, but we will not talk about that here. Again, this is how you get the first and the last elements. This is how you can print them. I'm just going through because we covered all of that at this point. You can change elements of the list, so they are mutable in this sense. So for example, here we say Newton, Darwin, Turing, and we made a mistake here, and we fix it just by assigning this element of the list with a new value. Note that we did not change this string. We changed basically the element of the list. So we just took one piece of information and substituted it with a different one. So we did not change the string itself. We changed the element of the list. Yes, and this is an example of immutability of a string. So you cannot change the, even though you can reference to the 0th, effectively the first element of the string, you cannot change it. So you can print it, but you cannot assign it. Okay, changes. Okay. Well, we already talked about lists, how we can append values to lists. Interestingly enough, they append 11 here, which is good. Yes, and this is how you can delete del. Now, if you can be, well, we'll do it after, yes, after this one. So there is a reverse method that reverses the list. And if we try to print it now, it will be reversed. But there is also, be careful to not confuse it with a function called reversed, because it does exactly the same. Sorry. So, okay. So list first, but it doesn't change the the list itself. So odds is still the same. The same actually applies to sort. For example, there is odds.sort. Oh, yes, and because I added 9, let me delete that. Odds 0, 1. Sort. So it doesn't output anything, but it sorts the elements of the list in this case, numerical. And there is a function sorted. Again, because it's sorted, you can assume that, okay, this is something that is sorted, so I will loop over that. Oops, sorted. Odds. Well, in this case, it didn't make a difference, but this function does not change the odds, the list. Now, if we assign a variable to 1, in Jupyter Notebook, we have a function called whos. I believe we can just type that. And we'll see all the variables that we have in our memory. And the values as well. Let me type del odds. What do you think happened? We deleted variable. So you can delete part of a variable of a list, or you can delete the entire list just by saying delete and the variable name, in this case, list name. Okay, any questions? Yes.
There's no print new line command, but how can these output new line?
No new line? What do you mean?
So these output are print to new each number is print to a new line, but there's no new line. Print new line command.
New line? Which lines?
For numbering, ask, print numbers. Yeah.
Here?
Yes. So the output.
So print adds a new line for you. And if you have a look at the help for the print, oops. So end, and this is the character that it ends. So /n is a new line, which this is a character that we don't see, like it's not printed, but this is how basically print works. It adds this invisible for us character. You can redefine it, and for example, if I well, this code piece of code will not work because I deleted odds, but let's say I just copy that and say for I in list, oops, okay, I'll type 3579. Print I end equals. So it will not advance to the next line. It will print them one by one. Yes. You can have space here. You can add anything you want, but well, if you find use for that, that's great. Well, probably you can find something, and just as a matter of fact, you can use tuples. So this is a tuple. Now, if you think about it, so functions use parentheses, and tuples use parentheses. And that's probably, it could be coincidental, but on the other hand, it means that you cannot sort of use the other approach. If you cannot add parameters to function without redefining the function. So that's how you can remember the relationship between tuples and function parameters. So once you have the function, once you defined the order of parameters and the number of parameters, you have to use this function with this many parameters. Of course, we are not talking here about advanced topics like classes and things like that, because technically you can't do everything, anything you want in Python. But this is like a mental model how you can remember that tuples are immutable and how they relate to function parameters. Again, I will close this because we are done with that. And as you can see, we are going much faster than before. Files, finally, the part that we didn't have in our mini shell lesson, because we had to get to this part. So usually software carpentry workshops, they take a full 2 days, and there are 4 sessions. Usually the first half of the first day is shell, like 4 hours of shell. The second part is usually Python, so that people can absorb the first set of information and come back the next day with questions. On the second day, we usually have either SQL or Git. And then in the second half, we have second portion of Python. And usually we do it this way because if people can come in the afternoon, like on day 1, they can come in the afternoon on day 2. So there is a relation, connection there. So here we have only 1 day. So I totally understand why it seems like maybe for some of you it might seem too slow. For some of you it might seem like a lot. It really depends on your level. Okay, so in order to work with files, we will use a module, and you already know what a module is. It's just a collection of functions, and when we import a module, we effectively refer to a specific file. So let's import glob, and glob has a function called glob. Perfect choice, I think. So glob, and this is how you can find all the files. Now I am in the notebook. Okay, so I just know that there are no HTML files in this directory, so let me see what IPython notebooks I have here. And I get a list, which is pretty good. Okay, so how is it related to our data analysis? Well, as you remember, we have a lot of people and a lot of CSV files. And let me first comment out this part. So what we do, cells, just a second. Okay, apologies. Okay, so what we do here is we load NumPy to read our data. We load a matplotlib, and we don't resist that notion to load it as PLT for convenience. Whoa, but we use it later. Okay, that's why I wanted to clear everything. Okay, we'll make it work. So we load the two libraries that we need, and we say, okay, file names equals sorted, glob, and then the pattern that we are globing over. As you remember, I mentioned in the beginning that star is a wildcard that replaces anything, any character. So effectively, this pattern means that we are looking for all .csv files in the directory called data, in a subdirectory called data. And we don't care about the name of the file. What we do next is we loop over these files. Now, if we try and execute this command, I don't know how to add the insert cells above. Okay. The B, Control M. Okay. Okay. So I just wanted to make a quick point. Is that so? Yeah, sorry. I think I need to import glob. Oh, sorry. Yes, good catch. Yes. So, so this is what we get from this file, and you see that we have a lot of different files like inflammation, small, inflammation, and they go into in right now in order because it's sorted. Okay. Now, okay, so this is a loop over file names. F is the name of each and every file that we load, and we go over these files one by one. We create three axes here, and we again do the same thing for all of them. And because I commented out, so if I remove that line, we would go over all the files in this directory. So we would have a lot of files, a lot of lines. But if we limit ourselves to only 3 data files, we can look at the results like in one place. So the first 2 files, they suffer from the same problem, is that the maximum is very suspiciously looking thing, and minimum also. Well, and average, of course. Now, inflammation 3 is a little bit better, but minimum value is 0, which is also probably not right. So this is how you can use glob to loop over files. Let's see. Nope. So let's do a mini exercise, and what we'll do here, we'll just change the files to loop over only files that are called small, and well, I guess that's all we can do here. So I'll just quickly do it because that's what we should do. Oh. Yes. So right now we are looking at 3 rows of data. They were generated automatically in a loop, so we didn't have to manually type anything. And if you had to type all these lines like 10 times, there is a chance that you would make a mistake. And now all of that is automatic. Okay, so we are done with that part 2, so we can loop over all files in our directory.
What did you change to get rid of your error when you initially ran?
I added back SPLT. Okay, so let me shut down this notebook. Let's move on to the next IPython notebook, 0.5 conditional statements. And this is where we will actually talk about if and else and else if, a fun form of else if. So sometimes we have to make decisions and do some certain operations depending on conditions. That's why we have Booleans in the first place. And here is an example of such a case. So we set num to 37, and that can be done by someone else, not us. And then we say that if this number is greater than 100, then we'll print greater. Otherwise, we'll print not greater. And in the very end, regardless of the result, we will print done. So what do we expect right now? We expect that it will print not greater, done. And this is exactly what happens. Now, the syntax for the if command, if you have a closer look, is exactly the same as for the for loop. We have an if keyword, then the comparison that we want to make, colon, then we have a new line, certain number of spaces, then the action that we want to do. We can have else. We might omit it. It's not obligatory. We can just skip it, or we can have something else, some other else if. But the idea is before that it should be indented, but you can see that those are separate statements. Okay. Then, well, this is pretty obvious. So this print is executed every time because it's at the same level as if. And this is not printed because it's not true. I want to talk about that elif thing. So this is a special case, and in some languages it has a different spelling. So they write it differently. Sometimes it else if one word, sometimes it's split in two words, else if. In Python we have that elif thing. It is considered and checked only if the first if is not true. So if the first statement is false. In this case, number -3 is not greater than 0, so this statement is false. Therefore, the next statement is being checked, but our number is not equal to 0. Therefore, it will be the last portion, else, that will be executed. And this is what we see here. So basically, this is a way to chain together conditional state verifications. Sort of, we say that, okay, if the number is not positive, so it's not greater than 0, then we check that, okay, maybe it's 0. Nope, it's not a 0. Then we say, okay, this is a negative number. There is nothing special about that. We can have a very simple explanation. If true, print true, and it will always work. And if we have if false, print false. We'll say, and you see that it did not do what I want. If false equals true, and I have to do it myself. Okay. Print what? And then else print hey. So This is a straightforward. So all you have to remember is how to write else if. Everything else is plain language. If, else. Don't forget colon and indent. So it doesn't matter what, how many spaces you use under each of them, but just be consistent. Okay, and this is a bad example actually. Don't ever do that. At least don't say that you saw that here. Okay, so you can, of course, you can combine comparisons just like you can do with Booleans, and we saw that in the very beginning. Again, whenever you see that, it's clear, okay, this is true, this is false, and what is written here, if true and false, what is not written here are true. But we know that as soon as we combine anything with false, it becomes false. So this is not the case. And we'll get that else executed. Now we can use or, which will look for anything that is true, and it will be true as long as, as long as there is at least one part which is true. And because the second part is true, so -1 is less than 0, it will print as a statement. At least one test is true. Okay, so this is what we actually can use when we check our data. Because we know, we see these lines, how they, the maximum and minimum, how they are suspiciously looking straight lines, but we have to have a way to check it. And one way to check it is to check against a certain value, certain data point against a certain value. And this is what we are doing here. So we want to check our data. So I don't believe we have data loaded, so this is just for us to see. So what we check here is that minimum value of data along axis 0, and axis 0 goes this way, so across rows. That means that this is an average across, the minimum across all the patients, equals 0. So the minimum value across all the patients equals 0. And maximum value across all the patients in the middle, here, the middle, almost middle. The correct way to write it would be 19, because there are 40 elements, and the 20th element is actually has index 19. Apologies. So, and the 20th element equals to 20, then we have a suspicious looking maxima. And because this is a maximum value across all the elements, we can say for sure that this is something is not right here. So if we can come up with some sort of other tests, we can add them here with else if. That's up to us. So let's just try it and see what we get with the first data set. And we get it. So we get this suspicious looking maxima. So something is not right here with this data set. Yes. Well, what I'm saying is that in the text, I'm not reading the text, I just know it, but it says that like in the middle, but there are 40 elements. If the description correct, it has to be 19th Yeah, but I guess the data was fabricated using these values. Okay, so again, this is just an example of how to use else if, and there is nothing magic about it. So what we do here is that we take data, our data, we find the minimum values across all the patients, and we sum them up. And we check whether this value is 0. And if this is 0, then that's not right. Okay. Let's answer these questions. Which of the following would be printed if you were to run this code? Why did you pick this answer? So if 4 greater than 5, which is false, we skip this line. We don't even read it. Else if 4 equals 5, not true, don't even bother reading the next. Else if 4 less than 5, which is true, print C. Yes?
So you had your first if statement as true, and then it printed, would it even go to an elif?
No,
Okay.
it wouldn't bother.
You have multiple elifs that were true.
It would stop at the first one because it assumes that you write exclusive conditions. It's let's just check it. I mean, it's well. Let me add the cell above. So, if 1 greater than 0, print 1 greater than 0. Then, if 2 greater than 0, print 2 greater than 0. So the presence of else assumes that otherwise, like if the first one, the first part is not true. So that's that else that plays a role here. Okay. Yes. So true and false are special words, and the capitalization is important, as I showed you that with that C variables, lowercase c and uppercase c, because you can assign one to integer, another one to Boolean, and that will work. So yes, so but they are not the only ones that are true or false. So you can check whether, for example, you can say if string. What would it mean? It would mean that if a string has a non-zero length. You can say if list. It would mean that if list has some elements. So, and this is what is actually they're talking about here. So, if empty string, print empty string is true. We don't see this line. Empty string is not true. If word, which is a non-empty string, and word is true. Empty list is true? No, it's not true. So this is how you can check. So for example, you want to check, okay, do I have any elements? You don't have to use that len of list. You can just say if list, blah. If list, colon, new line, do this. So you don't have to check the length of the list. And the same for 0 and 1. Any guesses what would happen if I say if 2? Like, what would happen if I say if 2? What should I print? Well, according to this example, it should be 2 is true. 2. This is also true. Any non-zero element is true. Okay. Now exercise. The exercise is to write some code that will check whether A is within 10% of B, value of B. You can use floats or integers. That's up to you. But 10% suggests that you should use floats. And compare your implementation with your neighbor. And while you are doing this, I will mention that in that Greg Wilson's video, he points out the practices that actually affect teaching and learning, things like that. And it turns out that peer sort of interaction with neighbors helps. There is a caveat that it helps only in the first couple of weeks. After that, it sort of dies off. So this is a useful technique if you can pair with someone. So I would suggest that you start with just assigning variables, and you can do that like so. So I'm looking at Slack. Just a reminder that values should be close to each other. We're not looking for values less than 10% of value B. Yes, see a good answer there. Okay, so let me briefly discuss So variable A is within 10% of the variable B value. That's what we are looking for. So I see a couple of answers on Slack where people just divide B by 10, but that's 10% of B. And there is an almost perfect answer. So let's have a look at this answer. I will comment out this part here. So in principle, this is a working example. It should work because what we do here is that we compute the difference. So okay, that will be our difference between two values, and then we compare that to the error. Now here we are using our OK error depends on the value of B. But what if B is negative? What if we compare like minus 44 and minus 40? Then we would have to have that, and then who knows how can we get a positive number less than a negative one, right? So this solution sort of implies that we use here this absolute value. And it's good that you are using that abs, because we did not discuss it. But yes, this is a function that gives us an absolute value. Now the straightforward way to write this is to say, okay, so first of all, let me recall. If A, it's up. If A is within 10%, so it's B that is set, and it's A that is sort of being checked. Okay. 10% of. So let's say of B. And if we use 3.9, that's true. What if we do that? No, there is no way it can be true, right? False. If we do that, true. And 4.1, false. Good. So this will work. But there is a good example on Slack as well that I want to show. And I will use this code. So I like this example because this is a basically the check is performed on a single line, so it's very easy to see. And what we check here actually sort of checks whether A is within a limit. And in Python, you can chain these comparisons. You can say times B, so A less than 1.1 B times B. And 9.1. So this is it. all other examples, I'm pretty sure they are whether accurate or yes. If a oh yes, I actually see this this exact answer. Yeah. So apparently some of you know this material. Good. Now, in-place operators I mentioned before. Basically, what we do here, for example, equals is the first operator that sort of changes the value in place. You don't do anything else with that. Plus equals also increments by 1. This is a very common way to increment elements in many languages now. Multiply by 3. Let's do that, and let's actually add period here and do x equals 4. So you can divide. So basically, any basic operation like addition, subtraction, multiplication, division, everything can be used with the equal sign here. Okay. Oh, this is a good exercise. So let me write you a list, and you will write a small code that will sum up all the positives and all the positive numbers and all the negative numbers. List equals -1, 4, -10, -1, and 5, and 10. Oh, sorry. So you just separately add them up. Just
Sum the positives and then sum the negative. And report the summation of the positives and the summation of the
yes,
negative.
yes. You can do that. Yes. So keep in mind that looping over something long can take a while. So imagine that it's not like 6 elements like here, but 6 gazillion elements. What do you want to do? Loop twice 6 gazillion times with having to care about only 2 variables, in fact. Or do you want to loop only once but update 2 variables? So for such short and very small list, it would make a lot of difference. But in HPC applications, in any data intensive applications that deal with lots of data, you really have to care about that. Well, the way, yes. So the way I would approach it is I would initialize 2 values, and I would increment these values if based on certain conditions. For example, the only thing that I used here that we didn't cover before is this example where A equals B equals C, effectively, where I assign two variables at once to the same value, 0. Everything else is straightforward. We loop over the elements of the list. If the element is less than 0, we increment the negative sum. Otherwise, we increment the positive sum.
Question.
Yes?
If you can get a character at a particular index of a string, why can't you iterate over the characters in a string?
You can.
Here you can go through numbers without having to say the string length. But you can't do that for a string.
Well, you can for that for char in string. Sorry. Thank you.
So that's right.
Yes. Char. And I apologize if I was not clear because that was one of the first examples, and I probably skipped it too quickly because the example there was for word in, I remember the second, tin. So we had something like that there. But the solution is here. Let me check if someone came up with a better solution. This one. Okay, so this solution I see is basically checks the number of positive or negative elements because it increments by 1. Okay, tuple. Okay. So the solution with using while seems like a correct one. And again, we did not cover while, but as you already know, you can do help while. And it will fail, I because you have to use that. Oops. But let me actually copy paste the example here. So again, this is a perfect example. It shows you that you can have spaces before equal signs, or you can skip it. Python will understand it. Just like here, while I less than length of x, which is this tuple here, x of I, if x is less than 0, we write negative, else positive. Yes. And then increment the index. Now, the so here, the solution. This solution requires one extra variable, I. So it doesn't loop over the elements of the array, of the tuple, but it lists over index, and then uses that index to get the value of the element in the tuple. So this is possible. This is doable, but you can also iterate over the elements of the tuple using the for loop. Okay, so tuples and exchanges, we touched this briefly. Basically, if you have two values and you want to exchange two variables, and you want to exchange the values of these two variables, so that, for example, left becomes right, or left becomes R, and right becomes L, then standard approach is to use a temporary variable. You assign it to left, you change the value of the left, and then you assign the right to that temporary value. But it requires that extra sort of coding effort. Now, in Python, you can do all of that just in a single line, and we already talked about that. Now, yes, because they are not initialized, of course, it will fail. Now, the question to you, do you think you can come up with a solution to swap three elements? Change them like, somehow in a complex way. So let's say you have so how can I make so that 1 becomes 3, 2 becomes 1, and 3 becomes 2? And please post the solution to Slack, so let's see what solutions we get there. So what should I write? Say it again.
1, 2, 3, 4, 3, 2, 3, 1.
1, then what? So, comma 2, 3. Okay, and 1, 2, 3. Yes. So this rule applies to any number of things you want to change, and the reason it works is that first, what it does, it evaluates this thing to the right of the equal sign, and then sort of throws it into the correct bin on the left side. So if you need to switch like any number of things, like 10, you can write that. Okay. So the next one is functions. So this is actually like the core of this software carpentry lesson. So functions, they're so important that this whole software carpentry Python training exists, because at some point you will find yourself working with code that that is either hard to read or very good to read, but it will be hard to read because there are no functions, and it will be good to read because there are a lot of functions and a lot of useful functions, so that it won't be a function like function X. It will be function compute standard deviation, that you will literally just read the name of the function, and it will be a function that you will understand the arguments to that function. It's very important to write something that you will understand yourself in 6 months. So I'm pretty sure a lot of you heard that the person who will have the most problems with your code is yourself in 6 months. There are a lot of ways of saying that, but basically it probably will be you dealing with your code, but it will be you 6 months later. And you'll have so many other things on your plate before now and then, so you'll completely forget about that, about what you did. So it's important to write that those functions clearly. That also makes the point that you need to add those docstrings to functions. You could see how functions, how we could look up that information that we wrote using those strings, usually easily by using help and then the name of our function. Basically, whenever you write something and you're happy with it, write a short string saying what you did here. And if this is a function, you can just write a string. You don't have to use a comment block or anything complicated. Okay, so this is our first function that converts Fahrenheit to Kelvin. And the key features of function is the def keyword, stands for define, I guess. Hopefully nothing else. A, B, C, G, E, F, maybe that. Then the name of the function, and in parentheses we have the arguments. In this case, we have only one argument, temperature. So every function has to return, at least at this level, that we care. And what it means is that whenever we call it, so the function will say, okay, this is my output. And if something needs my output, this is my output. So here we use regular parentheses to just subtract 32 from the temperature and multiply it by the scaling factor, and that's it. So let's try to execute that, and nothing happens as before. Nothing happens. That's great. That means that there is no error. However, it doesn't mean that the function is correct. It doesn't mean that. It means that there are no syntax errors in that function, but there can be some other errors. You could be calling something that does not exist. You could be using something that does not exist. It's not being checked at this point. So what Python does right now, it just creates this function for you. So, and we can use it in any function, other function, for example, print. That's more or less clear. We already used function type. This is also the function type. It's just a built-in, meaning that it exists in the plain vanilla Python. We don't need any modules for that. There are some functions that are not in the built-in pool of functions. For example, not everyone needs mathematical operations, and those are hidden in math module. So, for example, there is like a pool of standard operations, plus, minus, multiply, and things like that. But what about pi? We all know that there is pi, but if we try to say pi, it's not there. But in fact, it is there, and it hides in module called math, and it's there. And I encourage you to use help to read about math. Actually, the best thing that you can do after this workshop, in my opinion, is first of all, relax, like everything will be all right. And then use help a lot. And the way it works, the way that help works, you have to write something there. Now you know that if something is not in quotes, it's considered to be a variable or something else, something special. So if we type, for example, math here, we will get a help on math. If we type math.py, and let me remove that print statement, because I don't care about it at this moment, I would get a help on, actually a set of modules. Well, let me try that. I was expecting something else. Anyways, yes, so it doesn't print me what I want, but basically you can find all the methods, all the attributes in that module in this help message, like error function. It exists. So if you need it, exponent, it's there. Some fancy exponent, floor, and so on. There should be pi as well, but yes, greatest common. Okay, so this is the way you will find out things about like other modules. To find the modules that you actually have on your machine, on your computer, you type help. I believe it's modules. Yes. And it will output some errors, error messages, and so on. But in the end, it will give you the list. Where is it? Still working? Oh, I should scroll now. So this is the list of all modules that you have on your machine and that you can call help on. For example, you can call help, well, in my case, OpenSSL, help site. Actually, this is a good help to look at, a good help page to look at. I feel like we will not be able to cover some topics that I wanted to add. One of them was site module. So you can look at the help page of that module at home. Scikit-learn, so the very popular package for machine learning. Scikit-image, so a set of scikit images. Slacker, and this is a good module, and let me demonstrate guess who? Please check your Slack. If you have internet, and if I have internet connection, then you should be receiving something, a direct message. So Slacker is a module to work with the Slack API. And for example, in my case, I use it a lot because I use Slack to interact with participants of certain events that I'm organizing. So this allows me to do things in the command line. And basically, right now, people can, using Slack API, they can say, okay, this table in this room, like gaming table, is being used. So I'll wait 5 minutes. I'll come in to play like table tennis in 10 minutes. So there are a lot of possibilities. And okay, so this is the list of, and by the way, yes, glob that we used before. So list of modules. So in order to get help and to find out which modules you have, use help modules in double quotes or in quotes, single quotes will work. Okay. Division in Python, Python 2, we covered that. So 5 divided by 9 would be 0. You have to add a period either to 5 or 9, so that Python would think that this is a floating point number, so it has to do a floating point division. Python 3 does not have this problem, so it will always convert the result to the floating point number. Okay, so now we can talk more about combining functions and using several functions at once. So we defined that function before that converted Fahrenheit to Kelvin. But now we can write a function that converts Kelvin to Celsius. And the conversion is straightforward. We just subtract 273. But now we have two functions, Fahrenheit to Kelvin, Kelvin to Celsius. So it's straightforward that we can chain these two functions. And in order to do that, we'll just create a function Fahrenheit to Celsius that will use these two functions. So first, this is like our first attempt at the solution. we'll say temperature in Kelvin equals to Fahrenheit to Kelvin. So we convert from the temperature in Fahrenheit. And then our result will be Kelvin to Celsius. So this is good enough. It will work. And speaking of good enough, there is a paper, second paper by the software carpentry people called Good Enough Practices. So they talk about practices that you can use and that will help you write better code, collaborate with people, and be successful. So, but there is, of course, there is a easier solution to that. So the way to do that would be, of course, we do not need to store the result. We can just return it, right? So what I'll do now is I'll take that, Kelvin to Celsius, and I'll just return it here. But now, what about that temperature in Kelvin? I can just take that and substitute that variable in the return statement with this function call. And that's it. So our function right now uses only a single line.
The function is sitting somewhere else. How do you call it?
So let's say, good question. And let me do that right now. Oh, people, can you see that? Or should I? Or it's more. Okay, so. Let me just take this screen. This one. Okay. So func1.py at the bottom. Def. Oh, I copied those. No, I want to copy. Okay, so I'm lazy. Let's say this is that. Func2.py. Let me copy that function. So now I have two functions. Oh, one of them is func, and the other one is fun. Func and fun2, but it doesn't matter. So two functions. One of them has Kelvin to Celsius, and the other one has Fahrenheit to Kelvin. Now I can write a third one. Let's actually do that, Python 3. So I will import func1, import fun, fun2, sorry. Yes. Should have called it fun. And now what I can do func1 dot count to Celsius, then func. I guess I have to use, yes, this way. Should func2 that. Oh, maybe we should. Fahrenheit to Kelvin. So the only caveat here is that you will have to read it a little bit backwards, because this is the nested function, and you are converting from Fahrenheit to Kelvin, and then Kelvin to Celsius. So it's like boom, 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 boom. So you'll be jumping, but you can do that. And Fahrenheit, I don't know what's the reasonable temperature. 500 maybe. So. Yes, this is how you would use it. Oh, for the notebook. So in notebook you can save. I don't remember what's the magic keyword, but I think it's something like save and then file func.py, something like that. As a file. But I don't remember the actual, like, what you have to use. It probably not safe, but something else. Well, yes, if you remember that special command, you can just do that. Save, maybe it's save something. I thought it was save, but it looks like it's not. So if you use IPython notebook, you should definitely figure out how to save it, how to save blocks of code into a file, and then it should be fine. Although, honestly, I would be surprised if you end up working on a big project in Jupyter notebooks. So in my opinion, this is good for demonstration purposes. But in the end, what you care about is syntax, that it's correct, and that you write in a Pythonic way. So Google up Pythonic way, because a lot of, well, you probably know that, but a lot of times you will see a solution to a problem in Python language, which people for some reason call it unPythonic. And the reason is that in that solution, usually what people do, they just loop over some lists. And in Python, it's considered to be Pythonic to use methods, to use some fancy like dot something. So this is Pythonic, the most efficient way, basically. So of course you can do it in a simple way, straightforward way that you can compare against, but the final solution should be Pythonic. Okay, I think we covered that. Oh, where am I? So yes. Yep. So this is about our problem, again, going back to analysis of the inflammation data that we had. So again, all the lines here should be familiar, and you should know. And so what is now? So let's create an analyze function that generates our plots. So here it's called def analyze, and then it takes a file name. Now notice that it takes only a single file name. It doesn't take a list of file names. So it doesn't replace us the for loop that we have to have. Now we can, and yes, sorry, let's execute that function. So I will not like explain this this function because we looked at it many times already. Basically, what we do here is we load data, we create figure, we create axis, 3 axis, and we just plot it. So that's called analysis. Then we create a function called detect problems. Any guesses what it does? Detects problems. So here we implement exactly the same. Apologies. That's the problem. Okay, so this is the function analyze. Def analyze file name. And this is function detect problems. Again, it takes only a single file name. And this variable name could be anything, but if we use file name, we understand that this has to be a name of a file. And this is our main function now, how it looks. So we import glob to loop over all the CSV files, comma separated value. We use a loop for f in file names. Well, and we limit ourselves to 3 files only in this case. We print the name of the file, we analyze it, and we detect problems. That's all. So this is how you can use functions to simplify your sort of life when you need to understand what a function does. And as you can see, well, in this case, everything that we have here is effectively in a single file. So because this is in a single Jupyter notebook. But you just saw how we can split these functions, put them in a different files and access them from there. Okay. And yes, you also can notice that we have some output from that detect problem thing. Okay, testing and documentation. Now, I mentioned the importance of documentation, and I'm not probably the best person to convince you that you should do that, because it should be you who hopefully understand by now that documenting functions and documenting code that you write is important. For example, if you look at the this function, it's on the one hand you have center, data desired. So you have 2 inputs there. You compute the mean value of the average value of data, you subtract it, and then you add desired. So what it does, who knows, because there is no good documentation. But it's on the other hand, it's written well enough so it's even without documentation, you can spend a little bit of time and understand what it does. So the point here is that the lack of documentation can be overcome with a well-written code, but if you have documentation, it will simplify your life. So both things are important. It's important to write code well, and it's important to document it. Yes, so you remember how I mentioned there was a question about 3-dimensional array, and how I said that, okay, we have to create a list. In that list, we have to create a list, and that in that second list, we have to create 3 lists, then repeat, then repeat. So this is how you can create a 3-dimensional array with like 1 line. Well, here we assume that we loaded numpy as np. So we assume that we had import numpy as np before. And I believe this is what we did. Let me check. Yes. here. And this is the second notation that was used. So from matplotlib, we imported pyplot as plt. That's yet another way to write things. But it's the same import matplotlib.pyplot as plt. It's the same. I'll just follow that. Sure. So this is a already we have 3 dimensions here. Guess it will be easier to see using that. Yes, an example of 3-dimensional array. So we have big list and then list of lists. Again, list of lists. Okay, so center is that, by the way. This is a function. So we applied our function to our 3-dimensional array. So here, I keep scrolling back and forth. So here we are taking NumPy data. Data is not an integer. Data is not a string. It's a NumPy array. And the reason actually, also we can tell that this is a NumPy array, is because we use a NumPy method. Mean. Okay, so we can use that, apply that function center that we created for on our data, and to analyze it. And yes, so it will be. You can use it. That's great. I will execute it, but there is nothing that we did not cover at this point. Okay. So here we're just using some other way to check data, and where we compute the difference in standard deviations. Nothing important here. Okay. Now we can create a function that returns us an array. And this is a good example of a code that is commented out, basically with comments. And this is example of a code that you can call help on and get this statement in using help of center. Yes, which is here. So let me execute that and that. So, and this is called a signature, center, data, comma, desired. So it means that you have to provide data, you have to provide desired, both of them are mandatory, and none of them has a default value. So you have to provide both of both inputs. Okay. Yes, so what this does, it moves the center of data to 0, plus desired, like center, desired center. So this is a Well, if you're in data analysis and, for example, want to compute an integral of something, you have to first subtract the average value so that when you integrate, you don't get infinity if you have a very small step size.
Normalization.
Hmm?
It's just normalizing the data.
Yes. Well, it shifts the data. It's not scales it. It's sort of yeah. You see that every data point is we subtract the average value from from all the data points because this is a single value. So it gives us the average value of data, and then we add desired one. And so it's useful to give an example of how to use it because, as I said, I know that at this moment I know that desired is a single value. It's not an array. But I may forget 6 months from now. And if I add an example here, I see, okay, this is how I use it. This is what I will get. Okay, defaults. Defaults are important if you want to allow yourself sort of relax in the future and don't write everything all the time. One example is load.txt. If you look at the signature of load.txt file, you will see that it actually has a lot more arguments and parameters. So let's comment this out and do np load.txt question mark. So you see it has, well, it actually tells us explicitly this is signature, fname, dtype equals delimiter, and we did not specify delimiter, we did not specify converters, we did not specify skip rows. And the reason that we did not do that is because you see here it has equals 0, equals none, equals 0. And the only thing that does not have a default value is fname. So within that function, fname is the variable that is used in that signature. So we can specify just the name of the file without using fname equals. On the other hand, we can say explicitly that this is a fname. Now, where is delimiter? Yes, so the default delimiter is none. That's why it's important to use the delimiter if we are working with comma-separated values. So if we are working with CSV files, this is a mandatory thing. Okay, now dtype. Dtype defines basically the data type that we are loading into memory. It may turn out that the data that you have in a file has zeros, ones, twos, threes, and fours. But in fact, you are loading floating point data. For example, velocities or weight or height, anything like that. So you know that the data that is being loaded has a specific type, floats, for example. You can specify that type here because otherwise NumPy will make assumptions, and if it sees only integers, it will assume that what you are loading is an integer data, and it will assign dtype equals int 64 in this case, because most of the platforms are 64-bit today. So you can specify that dtype as well using dtype equals. So let's have a look here. Oops. Sorry. So you see that we didn't write fname equals string. Yes?
If you don't specify the delimiter, does it just treat every character as a different data value? Since it's none? Because usually we're specifying it.
So it will assume that there is no delimiter. But let's just try. I expect it to fail. Yes, value error, because it will try to do something with commas, and comma is nothing. It's not a value that it can load, so it fails because of.
Recognize like numbers otherwise, or
What do you mean numbers?
like what does it mean when you say the delimiter is none? Like what would that?
Treat everything as a. Huh?
The white space license.
Nope, it's none is not a white space. Probably the design goal is that you have to specify that every time. I don't know, but none is none, and white space is white space. Here, but note that we did not use fname. So we can leave without that. So this is a named sort of argument. So, and the reason that this is so because if we have two arguments to the function that we don't name, it will say, okay, I cannot guess which one is which, because you can have different order of your parameters in a function. For example, so it will do a type error, but you can say so you can sort of, using this naming thing approach, you can forget about, okay, I don't remember the actual order. Okay, the question is, who remembers now delimiter? Is it a second parameter or third, argument to that function? Nope, I don't remember, and I never do. I just call it. I just say delimiter equals that, and I don't care where I write it in the function signature. Now, if you look at the, I deleted it, but if you look at the help page for the load.txt function, you'll see that fname is the only one without the default value. So that's a way for you to say, okay, if I ever use this function with a single parameter that I don't specify a name for, with a single argument, that will be that parameter. So that will be that fname. I'm really not sure why they decided to use fname, because, okay, load.txt, that's pretty straightforward. I'm loading text, even though txt is short for text. But, okay, fname, why not file name? It's so straightforward. That's, again, one thing we'll probably have to live with. But again, this is something that could be improved in the future. That's only up to developers. And this is an example how to use the default value in a function so that we can skip this value when we call this function. Now, if we call so here we create some data, test data in p.zeros, two-dimensional array, NumPy array, And we call this function test data, and 3 is the desired value. But if we skip that test data, it will also work because it will substitute the desired value with 0. So basically, in order to get a default value for an argument in function, you just say equals something. Okay, this is yet another example of using center without specifying the desired value. Okay, nothing special. Okay, machine values. Let's just have a look what happens here. So when we specify at least one parameter, it goes round robin from left to right, assigning those values. And this is an example of I'm trying to fit. Okay, I probably should need to do that. Oops. So basically here we have function that has all arguments with default values, where we have basically we can call display, and it will output us 1, 2, and 3. When we specify first parameter, a is set to 55, and then and so on and so on and so on. Question: what would happen if I use 4 parameters? Well, the answer should be like straightforward. It will be an error. But what kind of error? Let's have a look. Type error. Okay. Yes, and you can, as I mentioned, with a load.txt, you can specify parameters out of order if because they have names now. And we already talked about the help page. Now, one of the other places that you have to consult with is of course Python documentation page, and this is especially important for pandas, because pandas is a module that works with big tables. It basically lets you work with very large data sets. They call these data sets data frames, and sometimes they change the behavior of their methods. So you should look for documentation on their website. Okay. Yes, adding two strings. Okay, let's do that. I think it will require 5 minutes. So basically, we have two strings, and we need to write a function that takes 2 parameters, and the names for these parameters are here, original and wrapper. And this function should return a new string that has the wrapper character at the beginning and end of the original. So that, for example, if we specify AB, we would get BAB. So what's the first keyword? Def, yes. Correct. Will that work? Even better. Or to print. Now, since we are talking about default values, we can assign default values here. Let's do it this way. Okay. And let's call it fence. And it will give us the same if we don't specify anything. Okay, already did that. Okay, are we good with that? Any problems? Because it's so there was a question if you can define a function and then later redefine it, and let's try it out. So def f of a, x, print x plus x. I guess your question was how to do that, right?
Saying that just put a function declaration at the beginning, but do not define at the end. Define that.
Well, you'll get an error here because that's part of the declaration. Or how would you do that? You mean like that? Because you have to have something. But what you can do here is you can do something like that. So pass, and we will talk about that because we have 1 hour. Pass means do nothing, just pass. But let's see def f of x, print x, and so print, well, f of 5. So it's let's see, def g of h, print f of h. So that would be a good test. So what we do here, what I do here, first I define f of x to do nothing. Then I say, okay, I have a function g that depends on like h or any other variable name that prints me the value of that returns function f based on that value. But then I redefine that f of x to actually print x. Now let's see what happens. It prints 5, which is interesting. So basically, you use that declaration. So let me use something else. Let me remove that and see and well, yes, see k. So here I'm using in function g. I'm trying to use function k. Now, as I said, so the this is not checked until you actually execute the code. If syntax looks okay, if it thinks that, okay, the function is written correctly, it does not execute the code itself. It doesn't compile you anything. But it uses the definition that it has in the end. So the answer, yes. And it's a good question. Okay, so the next task is to write a function that returns the first and the last character, 2 characters, the first one and the last one, as a single string. What's outer? Now, okay, so please have a look at this function that I wrote. Tell me, do you think this is the correct function, or yes? Correct, yes. So this is actually a good example of a sort of mistake that people have. So print function returns like unless there is a syntax error, but it returns nothing. So it prints stuff to us. We see it, but it does not return what we see. So the right way would be to do return. And it can be none. Yes. And
This, X has to be called input.
oh, sorry. Yes. Yes, of course. Input. Thank you. And speaking of input, it reminded me of a difference between Python 2 again and Python 3. So input is a way for Python to get input from you, from a programmer, from user. In Python 2, it was called raw input, raw_input. So that's why this Jupyter notebook highlights this input word, because this is a keyword. Okay. And outer. Here? Well, yes, technically yes, and this is a defensive. This is called defensive programming, because if the length of your array of your string is 0, you cannot access any of its elements because there aren't any, and we will talk about that. Okay, let's skip this, and let's skip this one. So just a second. So we are at 6. Yes, definitely we'll skip that. And we will not skip this one. So variables inside and outside functions. This is an important concept, because basically we are talking about sort of namespaces. So think of a space and think of confined spaces where specific names are reserved. For example, inside of a function, so function has some space, and let's talk about this function f2k. Variable name f is reserved for its input. So if you say inside of the function, if you say that this is f equals something, that will change the value of this function. Now, but what if you have variable f here? Like how do they work together? And this is exactly the problem that you might face if you are not careful. So let's have a look here. So first we define f and we define k. So this is a good practice to give some initial values to some variables that you plan to use. Now the problem here is that we define function f2k and say that, okay, it depends on f, and k value is obtained using this algorithm. Now let's do this. Print. Okay. Turn k. Okay. Print and print. So all of the functions they executed, and they assign the value of k. So everything is fine. But k, the last value of k here, will not be the last value inside of that function, because we did not penetrate into the function namespace. So here k is still that. Try functions with default values.
You say that these are two different k, so one is
Yes.
inner k and the outer.
That's why it's important to, when you, for example, import modules, it's better to do not do from module name import star, because different modules can have different, can have the same method name, defined, and this in this situation you will sort of override one with the other, because in this case methods are similar to variables in the behavior. But try functions with default values. See if it makes any difference or not. Oops. Okay. Now, in the previous example, so not in the previous, but before I modified it, the function was returning things, but we were not printing the return values. So in the end, we got 0 because k was set to 0 here. So whatever we did here did not affect us. Okay, so let's move on because we have yet another set of notebooks. And let's open the next one called errors. So we already saw a number of errors when we tried to provide a wrong number of arguments to a function, when we used incorrect indentation, and so there are different kinds of errors, and Python will tell you what kind of error this is, and it actually also gives us a way to handle these errors. So usually if you encounter an error, or I should say if Python encounters an error in your code, then it will stop execution. But there is a mechanism to actually sort of take into account certain possibilities that, for example, something can be 0 or and fail because of that, or something can go beyond certain limits. So that's why it's important to be aware of the approach that we're about to use. So import errors 01 is basically, as I showed you, it's a file that just has a function in it. And I believe it has a single function. Let's have a look at it, actually, before we import. Okay, so, okay. I don't see it in here. Should be somewhere else. No? Okay. I do not see it, but that's fine. It should work. No. So error. Where is this function? Okay, this is yet another example when module that you are trying to load does not exist. Well, but I believe this is not an intentional thing, because the idea is that it should not there should be a problem with the function definition, actually. Okay, that's why we will skip that. Let me have a quick look at that. Okay, there is no such file at this moment, but yes. So here. So here you can see module not found error. And all of the errors that you will see in Python, they will be something like key error, indentation error, something like that. And there are other examples: name error, index error. Index error is related to indices if you go beyond the limit of your list. Okay. That's fine. I want to go to handling errors. Okay. What kind of error do you think we see here? Well, yes, it will stop at the first one. Yes, once we fix that, it will go beyond. It will say that there is an indentation error. And that's why it's important to keep track of what you use. And you have to choose in advance whether you use tabs or spaces, and that has to be consistent. Here we are using 4 spaces. Sometimes people use 2 spaces because it's you can have more nested functions or sort of blocks of code. So now it should compile. Now it doesn't mean that you can you can have a mistake here, and apparently it will not work when we will try to execute it, because this is MSGE is not defined, so it will not know what to do with it. But it means that this is not an error like in that computer can detect, that Python can detect at this point. Okay. So again, this is exactly that. So we got that first one, but forgot the second one. So now we get this second error. Yes, and this is a note about tabs and spaces. If you're working in a text editor that uses tabs, but you received a code with like 4 spaces used as an indentation, and then you use tabs to change like small part of code, that will result in an error that it will be hard for you to spot. So it's important to use the same approach to indent things like tabs or spaces, but only one of those. And I'm talking about a certain, like a small piece of code, Of course, you can, in one piece of code, you can use tabs. Lower, you can use other function. You can use spaces. That's fine. And this is again okay. So here they are giving an example of such a problem, where here it is obvious that we have spaces, but this is a tab, and that will be an error. Okay. If it's not defined, if the value is not defined, it's a name error. Again, but so let's see, count number. Oh, that's actually okay. It's a good example. So what do you think is a problem here? Yes, so we forgot to define count. So again, this is the same problem here. And what problem do we have here? Exactly, yes. So it's important that we have the same capitalization. So it will be, again, the name error. And those were different, like, kinds of mistakes, but they gave us a name error, because in one case we used wrong capitalization. In the other one, we did not initialized our value, so same error message. So it's important that you know what you're looking for. Okay, and here letters is a list of 3 elements, and we get index error because we are trying to write element number 4, which does not exist. Okay, finally. So to work with files, and we did not talk about actually writing anything to files and reading files using a standard standard Python, plain vanilla Python. But to do that, you would usually use an open function, and you would say the name of the file that you want to open and the mode in which you want this file to open. Now, R means I want to read. If you want to read this file, that means that this file must exist. But this file does not exist, at least on my computer. And because of that, this line fails. File not found error. Now, it will not fail if we want to write it. But it will fail if we want to read it, and it does not exist. This is an unsupported operation on a file, but this is just to show you that if there is no method defined, you will get that, because it's not clear what you mean by file handle.read. And in fact, you should see like what you can do with that. There is a read, but it's not that. So if you add extra parentheses, you might get an error. So you have to know what is a method, what is an argument, an attribute, sorry. Okay. Now we saw a bunch of error messages, and all of them had the same syntax. Well, same sort of general syntax. Something error. I'm pretty sure it will fail as well because for some reason we don't have it here. Yes, so let's not bother at this point. Let me see if I can quickly fix that. Oops. Okay, so now I would like you to execute a git pull, and you should get those two files. In the directory that we created before website. So that website in your case is 2017-07 -10 and so on. Or in some cases it's actually a website. So you should see, well, in my case it's all up to date, but you should see download progress. Yes, and your okay. So syntax errors. This is a good example of a syntax error when we just added an extra space. But I want us to get to the should be here. Oh, it's probably in defensive. Yes. Okay. So it's in the next notebook that we will actually talk about that try and accept block that I see people already discuss on Slack. So basically, when you think that something might happen, you can add a try block and say, okay, I want to try and execute this code, but I'm okay if this code is fails. And if it does fail, I want to execute this code. And similarly to if, else, and else if, you can specify, you can say, for example, if I get this error, I want to execute that code. If I get some other error, I want to execute the other code. So I think we're good with that exercise. Do you spot any error here? Yes. So basically we have 4 elements, and again we use 4, and that means element fifth like element. So it's index error. Okay, so we are currently done with this notebook, and let's move on to our defensive programming notebook. Okay. Assertion. Okay, that's good. So sometimes you want to make sure, I guess we'll start with assertions, but we'll get to that try. At least, let me see if we have this try block here. It should be somewhere. Okay, let's talk about then try block first. So an example of a try block, I will use interpreter, but you can use a Jupyter notebook. That should be fine. So let's say we want to execute some code that can fail. So we would type try colon. Then in this case I will press enter. You don't have to do that. Well, yes, you have to use enter here. And then I would say, let's do print 1/0. So then I say except. And if I want to do something regardless of what kind of error I get, I say except colon, and then do print 2. And this is what I get. So this is an example of try and except block. Try except block accepts, you can specify what kind of error you get. So let's say, for example, try, without actually trying, do print a equals 1, 2, and 3. And we'll do print a of 3. So we get an index error here. So yeah, I don't see that now, but okay. So we can do try. Print a of 3. Yes. Now, we can actually make a mistake even in the that except statement, but the caveat here is that at this level, so we can write several excepts here, we will be catching the error related to that statement only. So we will not be catching the errors that we write in the except blocks. Except index error colon print 2. So in this case, it printed just fine, but I'll do a very simple mistake. So we did not catch that error, first of all, because of course this is a different type of error, but not actually because of that. We did not catch that because we were catching errors only related to that one. We did not catch even like errors here. So this is one of the examples how you can make a mistake even like when you try to catch an error. Now let's do it once again. Try. So I will do accept type error. So this is Control K to remove everything until the end of line. I will do pass, so I will not do anything if I get this error. Accept. Syntax error. I'll do print. Oh no. And then I'll do nothing. So this is how you can have several sort of attempts to catch errors, and you can execute different type of code depending on what error you get. This syntax also allows to use else statement. So in the end, you can yes, in the end you can have else. So sorry, the way to do that would be to do try, and this is oops. So there is also like finally, but I want to show you the else. Well, it's optional, but yeah, it's here. So try it out, see what you get when you get else. Try to make this else syntax work. So you try to generate an error that is not caught by any of your except statements, and see what this else code, else portion does. Okay. Now, defensive programming. So assertion is when you want to make sure that if something fails, if something is not right, then you don't continue. So that basically means if 1 equals 2 in so you compute something and something just has to have this value, certain value. And if it's not the case, you want your program to fail quickly. And this is called an assertion. So basically an assertion is a check that is fatal. The program cannot continue beyond the assertion failure. So let's have a look. We create a list of numbers, and somehow we know that it should be like positive. It should not be negative at all times. It could be an age thing, it could be our height, our weight, everything is a positive that is related to humans, human dimensions and measurements. So if we execute that, we get an assertion error, which means that we created an assertion that caught an error. that something did not work. And the way it usually works, and the syntax is as follows. You say assert, then the check that you want to perform, comma, and then the error message that you want to add. So, and this is what you see in the end. The error message. Assertion error. Data should only contain positive values. Yes, so skip that. Oh, this is a function that can, that doesn't compute the area, that, there was a function that computes the area. But let's see what this function does. Normalizes a rectangle so that it is at the origin and 1.0 units long on its longest axis. So basically the longest axis becomes 1 unit long. So this is our first assertion, that we provide 4 elements, so 4 vertices or coordinates in this case. Look at how this assignment is done. So rect here represents a tuple of all the arguments passed to the function. And beyond this point, so after this assert, we are sure that the length of the of this tuple of arguments is 4. That means that there are 4 elements. So that's why we can safely execute this function, this assignment. Now we can assert that our x0 is less than x1, but that's an additional assertion that in some situations makes sense, can make sense, in others might not make sense. So here we just do some calculations, and we do yet another assertion, and again we are using this chained approach when we chain our comparisons, and in the end we return the new coordinates. Yes, so this is a function, we used it. We executed it, so let's have a look what we get when we try execute it the first time. So assertion error. Rectangles must contain 4 coordinates, and we specified only 3. So now we specified all 4, but this time we get invalid x coordinates. And finally we get the right output. Okay. Again, we can do some other calculations and verifications. So that's just an example how you can have several assertions in the same code, and it doesn't cost you much to write one, because this is a very basic check usually, but it is useful. Yes, so range overlap, I guess this is a task, but we have 20 minutes, 24 minutes, and we have to cover 2 more topics. The question is, do you guys want to cover these topics, or are you lost even now? Because I feel like in the past couple of hours you guys were mostly lost. Or do you want some hands-on? We can spend 20 minutes for some just exercises. The next topics are debugging, and so debugging is the idea is that you'll work on the same piece of code with your neighbor, and command line arguments. So how to use, what module to use to actually read command line, to provide command line arguments to a function that you write. So we can skip the debugging part. We can talk about command line. That was in the original plan. Okay. So I'll then skip that assertion, and you can read. So the software carpentry lessons are online, so you can read them. They should be clear. So let's talk about command line. Yes. Command line programs. So we did not have the full bash lesson. So in the full bash lesson, one of the last things that we do is we, or actually not even the last thing, but one of the things that we do is we write programs that take user input from the command line. So the same way that we call commands, for example, wc-l, the same way we provide input to a program that we create. And we can do that with Python as well, but and this is an example of what we want to do. For example, we want to call Python to execute our script, our program, and say that we want to compute a mean value using data, this data file, or maybe this is a pattern. So again, this is why I mentioned head in the very beginning, because that was part of this sort of session. We can pipe the output of head command to our Python script, and it should be able to read it. Now, in order to work with standard input and standard output, we have to use modules, Python modules. So one of the modules that is useful and that you can use actually in your programs to do some checks whether you are in certain version of a Python is called Sys, and it has a number of attributes. So let me first execute this, and then do sys dot, and there is a bunch of arguments. So one of them is sys.ps1, and interestingly enough, have a look at this. sys.ps1 equals so this is our prompt. So this is contained this value, those three greater than signs, they are actually sys.ps1. And the same goes for that ps2. For example, if we want to write a very long string, you see these ellipses here. String, string. Whoa! Yes, sorry. That's the That's bad. Um, yes, so this is PS1. I just assigned it to greater than, no, greater than. And this is what I got instead of that. Now, I see these 3 ellipses here, and I want to change them too. And I'll just do sys.ps2 equals something like that. I don't know. And of course, it should be a string. And if I try to type it now, so I see these ellipses here. But this is just a game right now. No one ever changes PS1, PS2. Who cares what they are? So what we actually care about is a different beast. So I will do version, but actually you probably care more about version underscore info, but we will not talk about it at this moment. I apologize again. Yes. So we want a sys module because of argv attribute. So argv, who knows what argv is? Any C programmers? So in C there is argc, argv, basically count, number of arguments and values. So if you import sys module, you have access to that sys.argv. And in this case, you can see the list of arguments that was passed to Python, actually IPython kernel. But if I execute it in a script, I will see the list of arguments that that were passed to that script. And let's try that now. So I will create a file, test.py, and I will use Nano editor here. Huh? Apologize. Keep forgetting that. So I will do import sys. Then I will just print Sys.argv. So it should print me a list of arguments, but not only. So Python 3, no 4. By the way, I was the one who checked Python 4, just in case. That Paul. So argv contains the name of the script and the list of arguments. Now, if we execute the same code from a terminal here, from the interpreter here, import sys and print sys.argv. We do not get this because there was no file name, so this is empty. List that contains an empty string. Okay, So because above, you can see that when we call a script using Python 3 and pass some arguments here, script name is the first element of the list. So we can access it as Sys.argv 0. That would be the name of the script. Now let's go back to that part. So yeah, that's what they are showing us here. So the name of the script is the first element in the list of Sys.argv. No such file or directory. And just a second, I will fix that. Oops. So now you can execute git pull, and you should get the directory, code directory. And you should be able to execute it here, like so, git pull. So let's have a look at this script. So we define a function here called main, and we say that script is sys.argv 0. The name of the file that we want to process is the next input, sys.argv 1. Data equals numpy.loadtxt because we did import numpy and so on, so same as before. And then we do for m in data.mean across the first, basically this is a axis number 1, meaning this this second axis, print m, which is the average value. Yes. That's I don't know how many times already I did that. So yes, so once again then, def main, this is a main function of our script. It will not be executed unless we call it actually. And then we say that script equals sys.argv of 0, file name sys.argv of 1, data, and so on. Okay, so this is how we can process single file. But of course, we would have to call this function, main function here. Now the second Python code, Python program that we can have is here, where we simply add this call, main. Let's try that. So let's add a cell here. Let's do Python 3. That. What do you think we'll get? Okay, we get that. Now, this is a way basically for us to write again these scripts that handle that work with multiple files, and we can again because we have access to all the arguments that that we pass to the command, we can choose what we want to compute. For example, right now we computed the average value here, so data mean. But what if we pass an argument that would be -- max, and if we pass this argument, we compute the maximum value, and we can do that because we can compare the string that we pass to the function with the with predefined string effectively. And this is what I hope. Okay, this is not exactly what we do next, but we will do that. I think it's one of the next steps. So here basically what they do is they say, okay, so you have a script, but you should be able to specify as many file names as you want, not just a single file name. That's why here they have a loop, for loop, so that goes over all the inputs on the command line, skipping the first file name, skipping the first, which is name of the script, starting from 1 till the end. We load data and we print that. And again, this is an example how it would look for the following code. Okay, and finally, this is what I was talking about, the action part. So we can choose what action we want, what actually quantity we want to compute. In this case, this is we pass it as a second argument. So basically, we say that the script is the first one, and then it has to be the action. And after the action, we would say the name. The names of the files that we want to process. So how do we compare? Well, first of all, we have to make sure that what is provided on the command line, the action, is one of the options that we accept, and we can accept min, mean, and max with 2 dashes. We could add more to that if we wanted, but that's totally up to us. So the way to read it is that assert that action has to be one of these 3 elements, and we say that okay, if it's not the case, then we just add this message here. Now we go over all the file names, and file names again is a list, is a sublist of Sys.argv. So we go over that list and we call the process function, which has not been defined yet. So, and then we define the process function. We say that this function takes 2 arguments, file name and action, and that we choose which, depending on which action was specified, we call a different function. And we just say that, well, in case if we pass dash dash mean, we would compute data.mean, and so on and so on. And that's it. So this is how you can parse the command line arguments. Of course, you can say that, okay, but what if I specify, like, instead of, I don't want to use dash dash mean. You don't have to. That's just an example. You can assign that dash dash mean. For example, you can use just mean or just something m or 1, anything. It has to be the code that you understand and that other people will understand in the future.
Suppose they're exclusive, you can only have one of them. You can only put -.
Well, in this case, we can have only one because of this line action here. The way we handle this at this point is we write it here so that we handle only one action. In practice, like it does make a lot of sense because, okay, what if I want to compute minimum and maximum? That's actually easy to do. What you will do in that situation, you would parse a list and find all these strings, because all of these arguments are strings, and find all the strings that has the first character as minus, for example, and then you take this element out of that list, and you save that, okay, I want to perform this action as well as some others. So you find all these minus elements, and you record the actions that you want to do, and then you just loop over all the actions that you would do. This is just an example how, like the first approximation, how you would do that. Okay, and yeah, of course you can do a lot of fun games with the different modules, count, stdin, but I'll leave it to you, so you can try that for yourself. Let's see. So well, there are some other improvements. Yes, so here basically we say that if there are no file names, that if we didn't specify any file names on the command line, we can process standard input. And standard input is sys.stdin, and then action that we will do. Okay, and I think it's 5:31. Congratulations, everyone! You made it. And I apologize for that constant in the last 2 hours. Problem with the browser window being on top of the terminal and vice versa. But if you have any questions, let me know, and thank you very much for staying, for being here for whole 8-9 hours. Congratulations.